Hi, and welcome to the first PyTorch video in a series that I am going to be creating here on the channel. This video specifically deals with tensors, which is the backbone of PyTorch. What we're going to do is create a few different types of tensors. We're going to multiply them across through some matrix multiplication. We're going to add and also subtract them. At the same time, I'm also going to cover a few different concepts like dtypes, as well as devices, where we can create some device-agnostic code. And then rounding out the tutorial by showing shapes. So you're going to learn quite a lot in this video. I expect it to be well over 30 minutes. If you're excited to jump into PyTorch code, this is going to be that video for you. All right, I'll see you all on my computer and let's start coding. All right, let's get started in this tutorial. I have a Google Colab notebook. First thing we're going to do is we're going to import in a few different libraries. Now, luckily with Google Colab, you already have PyTorch installed, so you don't need to pip install it over here. So we're just going to import in torch. And then another thing we're going to do is import in NumPy as NP. And NumPy is used quite a bit when you use PyTorch. So that's why we're going to be using it. And you'll see it also a little bit in this video. So I'm going to click run. It's going to take probably about 10-20 seconds to have this run in your backend. And then you should be good to go. So you can just create a new cell with this code. And we are going to start with building out our first tensor. Now, think of tensors as kind of like arrays for PyTorch, but you can kind of represent anything through tensors. Like you can represent audio or images through it, and it's gonna be your basic kind of like building block for PyTorch. So let's build out our first one. So I'm gonna just call this tensor1 over here. So tensor1 and underscore tensor1. We're gonna say that's gonna be equal to torch.tensor. And then what I'm going to do is essentially put an array in here. So let's do like 1, 2, and also 3. Okay. And if you want to see specifically how this works out, we can just do a print over here. So let's print out our first PyTorch tensor. And essentially what we did, throw in a list over here, ran it, and here we go. Okay. So then just put a comma over here, and then we're going to say tensor number 1. So let's run this code, and it says our first PyTorch tensor, and you see tensor 1, 2, 3, which is great. Now we can do also is we can essentially call a NumPy array on the outside. So let's just call this as array 1 equals np dot array. And we can do the same thing, right? So let's put in here 1, 2, 3. Okay. And here's how we can do that. So we just call that, build another line of code. And then we're going to say this is tensor from NumPy. We're going to say that's equal to torch.tensor. And then put in here your array. So I call this array 1. You can just call this array here. Okay. And essentially our first PyTorch, we're going to change this to PyTorch tensor from NumPy array. Okay. And we're just going to put this over here, and our output is going to be the same thing. We're going to have tensor 1, 2, 3. Have this right over here. Let's do that. And PyTorch tensor from NumPy array, we have tensor 1, 2. Now I'm going to show you a few other ways that we can create our tensors. So I'm going to do an empty tensor now. So we're going to say empty tensor, and we're going to say that's equal to torch.empty, like this. Okay. And I'm just going to put 3 in here, not 2. And then we're going to print this out, and you can see that we didn't define any values, but we're just going to call it empty tensor, like this, and throw in your empty tensor over here. And I know this is like really easy right now, but I can promise you that PyTorch does get a lot more difficult. It's kind of nice though to get at least some of the basics down before we go there. So that is our empty tensor. Next, what we're going to do is we're going to fill our tensors with zeros and also ones. So pretty easy. We'll say 0 tensor equals, and you can do torch.zeros like this. Okay, 2 and also 3. And then we're going to do a print over here. And we're going to say our 0 tensor. Great. And let's throw in our 0 tensor. See what this looks like. And should just be no E in here. And you can see all the values on this tensor were zeros across the board. We can do the same thing with ones. So let's just copy this and we're going to say 1 tensor. So 1 over here. And instead of zeros, what we're going to put instead is 1. So ONES. And then we're going to print out our 1 tensor. And you can see this is printed out with all ones across the board. Now, another thing that's very common is doing a random tensor. So we'll say random tensor equals torch.rand, like this. And this time we're going to change the shape of it. Let's say we're going to do a 3x3. And let's print that out. So print, and same thing as before, essentially, right? Let's just copy this over here. We'll say random, and we'll put random tensor. That's, and you can see that these are all randomly generated. These go from 0 to 1. All right, and one more to show you guys. We're going to do an arrange tensor. So I'm going to call this arrange underscore tensor, and we're going to see that's equal to torch.arange. And let's go over some of these hyperparameters. So first you want to define where you started at. For simplicity's sake, I'm going to say start equals 0. Then your endpoint, so I'm going to say end at 100. And then you can talk about how you want to step. And I'm going to say step 10. So it's going to print every 10 to this tensor that we create. I'm going to just copy this code over here for the print statement. I'm going to say arrange over here and throw in our arrange tensor. And you can see 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. And it doesn't print out 100 because we stopped at 100. If we went to 101, it will. So if I just change this to 101 over here, right, it prints out 100 like that. All right, so we can actually grab elements from our tensors too. So I'm going to be using this random tensor over here and show you a few different things. So first thing I want to do is grab the middle element. So let's say we want to grab this 0.479. Let's do that. So what I'm going to put over here is random tensor like this. And what we're going to do is grab 1 and 1. Remember, with Python, you start at 0. So think about it, zeros right over here, and then 1 in each direction. Okay. And you can see that we grabbed 0.4579. Great. Now, if we wanted to grab the second row of the tensor, we'd use a code like this. So let's just say random tensor again. Okay. Then we're going to put 1 over here. And then we're going to put a colon at the very end, right? And you can see we grabbed 0.6193, 0.4579, and 0.96, which is great. Now, let's say we want to grab this first column, this 0.568, 6193, 0.7245. So I'm just going to copy this. We're going to keep the colon first, and then we're going to put a 0 here at the end, okay? And you can see 0.568, so 0.568, 0.6193, and then 0.245. So pretty easy. We can grab one specific value from our tensor if we really wanted to, or we can grab our specific rows or also our columns. Now, if you want to grab just the specific elements, so like I have this random tensor over here. Now it shows tensor 0.04579. But one thing you'll see a lot with PyTorch code is putting item. Now, this is just going to grab the specific value this time, right? So over here, you see that's still a tensor. Over here, we have a decimal number, 0.4579. Now, we can also reshape specific tensors. So I want to show you how we can do that pretty easily as well. So let's do that. Let's call our first thing is a reshape underscore tensor. And what I'm going to do is equal to torch.rand. And I'm going to make a 5x4. Okay. So we have this over here. And I just want to print this out just to show you guys what this specifically looks like. And I'm just going to say reshape like this. Okay. And you can see, right, we have 1, 2, 3, 4 columns, and we have 5 rows, right? 1, 2, 3, 4, and also 5. All right. Now let's try to resize this. So kind of interesting how we can do this. We can use this through a view. So let's say our new reshape tensor is going to be equal to, we have our reshape tensor over here, right? And I'm going to say dot view, and it's very common to put -1 first, which allows PyTorch to resize. And then I'm going to put over here the number 2. So we currently have a tensor, right? That is 1, 2, 3, 4 columns and 5 rows. This time we're going to completely reshape this. And I'm going to say over here, reshape tensor 2 equals new reshape tensor, and check this out, right? So now what we have is 2 columns, which we defined right over here, right? And PyTorch is automatically figuring out that we need to have how many rows? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We just performed a transformation on our matrix. Now the math behind it is pretty complicated. And we have just completely transformed our matrix. Not matrix. And now we have just completely transformed our tensor, right? We had this original shape, and now we have this brand new shape. So kind of a shortcut, put -1 over here, and then put how many columns you specifically want. I put 2, and that's why we have that. And make sure it is specifically compatible. Compatibility of your different tensors is important with multiplication, but we will go over that shortly. I also do want to show a few different ways that we can add or subtract our tensors. So here's how we can do that. And I'm going to create some brand new code down below, and let's get started. So let's define a few tensors. I'm going to put tensor A over here. We're going to say that's equal to torch.tensor, and let's just put in a list over here and define what we want. So I'm just going to say super easy 1, 2, and also 3. Then what we're going to do is have a tensor B, which is just double this, right? So let's go 2, let's grab 4, and let's grab 6 and throw those both in over here. So we're going to say results add 1 is going to be equal to, and you can just say torch.add, and because I'm going to do some subtraction a little bit later, I'm just going to put tensor B first, and then we're going to just have our tensor A like this. Okay. We're going to say results add 2 equals, and I'm just going to copy this over here. Right. We can have tensor B and tensor A. And then we can have results subtraction sub 1 equals, and this is why I just wanted to copy this and paste it. Pretty easy. And then let's just print these out. Print. And we'll grab over here. First one, print, and grab these others. So what we expect, 369 and 369, right? You can use torch.add or this. Personally, I kind of prefer this than torch.add, but use the preference that you want. And they subtracted, right? 246 minus 123 is going to be 123. And there's a few other ways that you could add too. I'll show you one other. It's element wise. So what we can do, put over here is tensor B, and we're going to say dot add, and then you put a underscore. So we're going to be adding directly to tensors B, and the result is going to be stored now in tensor B with this. Okay. And what we're going to put over here is tensor A, right? So we should get, again, 369 on this case for tensor B. And you can see 3, 6, and also 9. And if we wanted to do a print of tensor B now, right, just to show it wasn't just over there, you can see tensor B has now been modified where we have those results. All right, so now I want to multiply tensors, but there's a little bit of complexity because you can't just multiply any tensors. You're going to get errors associated with it. So this goes back into kind of linear algebra and how you multiply matrices. And I'll show you like a super quick trick on how, if these were compatible or not. And this brings me back to my math competition days. Don't remember all of linear algebra, but we used to have some questions like this. And since we didn't teach it at my school, I had to teach myself linear algebra, which is kind of fun. All right, let's go through this. So this hack really is simple. So let's say we're going to be multiplying this 2 by 4 by this 4 by 3. Well, these are going to be compatible. And the reason why they're compatible is this inside part. When you're going to be multiplying out matrices, or in this case, tensor, you have to make sure the insides are exactly the same. Now, if this was a 3 by 3, 2 by 4, and a 3 by 3, these are not compatible, right? You can ignore the outside sections. We have to make sure that these are the same, right? This could be like 80 over here, right? But we have 4 by 4, and that's what matters. So very quickly, you could figure out your specific sizes of your tensors and make sure that these are going to be the same over here. So I'm going to keep it pretty easy with this one, and we're going to build out a few new matrices over here. So I'm just going to call this a matrix A, and we're going to have matrix B underneath it. Again, kind of like matrix multiplication. And we're going to see this is torch.tensor. Okay. And inside over here, let's have a few different brackets. We're going to say our first one is going to be a 1 by 2, and a comma, and we're going to have 3 by 4. And I'm essentially going to just copy this code. So I'm lazy. I'll put this over here. We'll do 5, 6, 7, 8. Now, these sizes are the same, and we can multiply based around that. There are different sizes. Again, what I showed you, make sure the insides are going to be compatible, and that's the way you do that. But let me just run this over here real quick. I'll just do a print really quick so you can see how this is represented as a tensor, right? Very simple, 2 by 2. And if you go back to what I was talking about, right? And we'll just move this over here, 2 by 2, and then 2 by 2. These are compatible because we both have 2 here on the inside. So we'll remove that over here, and I'll show you a few different ways. So essentially what we can do, all right, so now let's multiply these across. So here's how we can do it pretty easily. Let's grab our results, multiply equals, and then you can do torch.mm. Then let's grab in our matrix A and also matrix B. Then let's print this out. Print out over here. And just like that, our multiplication is going to be done. Okay, and I want to show you another thing over here. Now, this isn't technically matrix multiplication. Instead, we're just going to be multiplying each of the elements. So, like, as I showed you how these were built out, then I'll just show you again, right? So, I'll say print. Well, let's do it actually after this code. So we're going to remove these over here, and we'll add in a few other cells. So let's print out first, print. Let's grab our matrix A, and then I'm going to print out our matrix B on the next one, and explain how this works. So we have matrix A and matrix B. Well, now what we're going to do is just straight up multiplication. So like 1 times 5, 2 times 6, 3 times 7, and then 4 times 8, which is not true matrix multiplication like you would think of in linear algebra. But this is accomplished through torch.mul. So we can just over here multiply 2. I'll just name it that. And we can just do torch.mul, right? And then we get over here 5, which I talked about, right? 5 times 1, 2 times 6, 12, 3 times 7, 21, and then 4 times 8, 32. You can see that is quite different than what we have over here, which is 19, 22, 43, and 50, because this is true matrix multiplication like you would think of in linear algebra where you're going to be multiplying across rows and columns. This one is just each element is going to be multiplied across on that side of things. Now we're going to take a look at dtypes, and that's taking a look at specifically what type of elements are in here. Now, like 1, 2, 3, and 4, like this is going to be an integer, but if you have like 1.1, 2.2, you're going to be thinking of a float, and it's good practice to declare what type of dtypes you are using. And if you are going to be mixing a few different dtypes together, PyTorch does know what's happening, and it'll automatically work through promotion. So let's say you're adding over here these integers with a float, it's going to automatically have the result be a float. But I still think it is kind of important to show you how this works. So let's print out a specific dtype. So we've had over here, let's say our results multiply. Let's do this dtype. So we can see over here dot dtype like this, pretty easy, right? Now I've also declared a random tensor earlier, and I showed you that they range from 0 to 1, and we had decimals associated with it, which is going to be a float. So let's do our random tensor dot dtype like this, and you can see we have a torch.float 32, which is great. Okay, now I want to show you how you can define these early on if you wanted to make any specific changes. I'll also show you how you can do that. Well, let's start it off. So let's say we're going to do a tensor, which is going to be an integer. So tensor int, we're going to say that's equal to torch.tensor. Then inside over here, we're going to do 4, 5, and also 6. Okay. And then what we're going to say is our dtype equals, and then I'm going to say torch.int 64. Okay. So now, which I made a mistake because I needed to put this over here like a list. We have defined our tensor, which is going to be over here 4, 5, 6, and we're saying our dtype in here is going to be this torch.int 64. Okay, so let's show you a few things. Let's say our print out. We're going to print out first our tensor int, and then what we're going to do is just have another print statement. I know I could just do one line, but we'll just do dtype like this. And there we go, 4, 5, 6. And then our torch is going to be an int 64. Well, let's say we wanted to change this int into a float. We're going to do some addition later, and we're going to be dealing with some decimal numbers. So just show you very quick. It's super easy. So let's have tensor float. And we're going to say float equal tensor underscore int dot 2, and then you define what you want. So I'm going to say to torch dot float 32. Okay. And I'm going to run that. And I'm just going to just do the dtype this time. Dot dtype. And there we go. We have a torch float 32. And if we wanted to print out our tensor on this side of things as well, right? 4, 5, oh. And if we wanted to print out our tensor too, let's just grab this print statement, and we're going to put our tensor float in here. And you can see it's 4. And now we have a decimal place in here, and pretty easy to change it up. And that is what we specifically did. All right, so now we're going to be taking a look at specific devices where we can run this code on. Now, through this tutorial, I've been using a CPU, but you do have the capability to run this code on a GPU. And Google Colab makes it super easy because Google Colab has a built-in GPU that's 100% free to use. So I'll show you how we can do that. But first, I want to show you specifically what device our tensors are on. And I've said that we're on our CPU, but let's double check. So we're going to look at our float first, and you can do tensor float over here, and you can do dot device, and it says type equals CPU. Now, defining the specific device matters quite a bit because you are going to run into issues if you have some of your tensors on CPUs versus others going to be on GPUs. And you can make that device-agnostic code across the board. Let me show you how you can do that. So what we want to do is we're going to say device equals, and we're going to do torch.device, Now, the first thing we're going to put over here is CUDA. So CUDA, and that's going to be our GPU. And we're going to say if torch.CUDA underscore is available. And I promise you'll memorize this code because it is used all the time in PyTorch and documentation that I've seen in different. And this code is used all the time in a ton of examples that I've studied as I've been learning PyTorch. So, and we're going to say else CPU. So CUDA will allow your code to run faster. I'll show you again how we can change this up, but make sure you do your device over here. Now, if you remember earlier, right, I used this .2. Well, we can also use this .2 essentially with devices. So here's how we can do that. We can say our tensor float, and I'm going to just grab this. We're going to say .2, and then over here, we're going to put in our device, right? And this essentially would change it to the device. Now, I'm currently in CPU, so nothing is going to happen, right? It's already a CPU, and you see like this, right? Still on our CPU. So nothing's changed. But let me show you how we can do this really quick. So I can go over here to runtime, and I can go to change runtime type, and you have all these options over here. Now, I am using the free version of Google Colab, so I don't have a bunch of premium GPUs. You can see purchase additional compute units and everything like that. I'm just going to use T4. Now, this will terminate your runtime, so you can see none of this is defined. So I'm going to have to go back over here and import torch and NumPy. This will take a little bit, right? But we are now on our GPU. So let's grab our code over here. And now, if we wanted to see our device count, you can go over here and say torch.CUDA.device count like this. And we have one CUDA on this side of things. And you can change your code as well. You can just put CPU here to check our CPU tensors. So I want to show you how we would do a brand new tensor with some of the different stuff that I've taught you so far. So we can just go over here, tensor new equals, and we can say torch.tensor. Feel free to define it how you would like. I'm just going to put over here a few different numbers. So I'm going to say 5150. Okay. And then I'm going to say 46 and 2. Next, what we're going to say is our dtype equals torch.float 32. And then we're going to say our device equals CUDA because we have this on the GPU. And we do have an error over here, and it's because I put floor, not floats. And there we have it. Now, I want to show you one other thing before we go on this video, and that is the shape. Now, the shape is going to be really important. I've already talked about matrix multiplication, but when you do start building out PyTorch models, the shape does matter. So how we can do this is pretty easy. Over here, just put in dot shape, and you can see we have a torch size of 2. Now, I don't have a lot of this code from earlier defined anymore because we are now going to be using the GPU versus the CPU. But I'm just going to run this random tensor again, and just to show you what this shape looks like here. And you can see that this is a 3x3 tensor, and that is why we have a 3x3 versus this one, which is 2. Pretty basic. So let's just do a quick recap because we did cover quite a lot in this video. And this is, like I said, first video in a series of PyTorch videos I'll be making out. And as I said, this is going to be only one video in a full series of PyTorch videos that I'm creating because I'm still learning quite a bit and I want to share the knowledge as I learn. So first over here, if we want to start with PyTorch, you import in here torch. There's a lot of different ways that you can specifically create your tensor. I showed you like a Python list over here, right? You can do a NumPy array, throw that over here. You could have an empty tensor. You could set it with zeros. You could set it with one, random numbers, and even arrange. Now, you can grab specific elements. So, for example, in this one over here, I want to grab 0, 7, 6, 2, 1. So I did 1, 1. Grab rows or specific columns as needed. Now, if you wanted that specific items element, you just put dot item, like that. Now we can also reshape our tensors, which is going to be really important. You'll see reshaping all the time in PyTorch code. So this is the example. We set a 5x4 and then I reshaped it. Remember, we put -1 over here. Oh, I should mention when we reshape, use .view. I put -1 over here. So that way PyTorch automatically resizes this and you don't have to really think about it. And then I define how many columns I want over here. And that's why we went from over here, right, to this 2. So this is 5x4. This is going to be 2x10. Then we can add our tensors over here and subtract. I showed you basic torch.add over here. Also showed you how we can do it basically by an element, although I don't like it as much. I showed you matrix and multiplication, which is torch.mm. If you just wanted to multiply your matrices over here, or I should say when we're talking about tensors, but you're going to be torch.mul. So remember, normal matrix multiplication that you think of like with the linear algebra. Torch.mul, we're just multiplying across the elements. Okay, then I showed you the dtypes. So it's important to have the correct dtypes, but it won't always throw errors, unlike the specific device. Remember, by default, you're going to be using a CPU, but you can use device-agnostic code. This one right here, torch.device, CUDA. If torch.CUDA is available, else CPU. So that way, if you have a GPU that you can use with the code, it uses GPU. Otherwise, it defaults to a CPU. You will see this code all the time. So make sure you study it, practice it, write it out 5 times. Promise you, when you write a lot of PyTorch code, secondhand, super easy, right? And then we can do toDevice, kind of like how I did over here, toDtype, right? So I changed this dtype over here to torch.float32. I put .2, we put the device over here. You can find your count over here. So device.count, you see we have a CUDA over here. And I just showed you how we created a brand new tensor, right? We put in just a list over here to keep things simplified with 2 numbers associated with rock. If you know those, let me know. Then we did our dtype over here and also set up our device. And to close out the video, I just wanted to show you shapes. So covered quite a lot. Just do a quick refresh of this code before moving on to the next video in this series. So if you found a ton of value in this video, and if you did, make sure to subscribe to the channel. It's 100% for free, but it does allow YouTube to share this channel and videos to other people online that are either getting into data analytics or also data science. As I mentioned, this is the first video in a PyTorch series. I have a few other model videos out right now, but I'm going to be covering the intermediate steps within the next few weeks, uploading at least 1 to 2 videos every single week. All right, I'll see you in the next video.